Okay. So, last class I have taken about that manner and place of articulation. I have described what is manner and what is place of articulation. Based on the manner and based on the place of articulation, the IPA symbols we have discussed, and we assign an IPA symbols. So, and we said that the vowels, all the vowels are classified based on the tongue position and tongue height. So, F1, F2 and F3, their relationship I have discussed. Now, today instead of taking a lectures, today I give you some demonstration to see the voice sound and identify the manner and place of articulation. We cannot identify by viewing that pitch sample, but yes, we can identify the manner of articulation, and from there we can see what kind of consonant it is, what kind of vowel it is, how the formants are moving, or kind of things. So, those we will explain. So, if you see, there is a number of open source softwares available, the CoolEdit, Pratt, then I have Web Surfer. So, I have explained in one slide that lot of open source the speech processing softwares are available. Now, one of them are the CoolEdit. If you see the CoolEdit software, that is also downloadable from the CoolEdit Pro, is downloadable from the net. And then if you see that when you open a voice, I have recorded that this let us I give you an example. Let us go through that. This is an example of a voice which is recorded for an English speech. Let us see listen that voice. Okay. So, this is the voice which is recorded by an English speaker, English speech, some sentences are there. Now, if you see that this x axis which is written the sample, number of sample, as we discussed in signal processing, that once you recorded the digital speech, that this is this x axis is sample, number of sample, or it can be time or sample, then y axis is the amplitude. If you see, this is the amplitude. Okay. Now, if you see this portion, no speech, that amplitude of the samples are very low, almost close to 0 line. This is 0 amplitude line. So, 0 line. If you see that this is recorded with 44 kilohertz 16 bit mono. So, each sample is you can say that it is quantized using the 16 bit. So, some value of the 16 bit is there, based on that value it is y axis is that value. So, it is a this is 0 axis, this is minus, this is plus, and samples are all samples are plot, and this is look like a sample speech signal. If you see this portion is the silence portion, and there here is a voice portion, there is a noise portion, noisy kind of signal. If I can magnify it. So, if you see that this is noise kind of things, if you listen it also, some noise signals are there. Okay. Now, if I see that okay, this is a time domain representation of the speech signal. Now, there is another kind of representation which is called spectral view. Look like a, you can see this is look like a mostly X-ray plate kind of things. So, here what is there? It is called 3-dimensional plot of the speech signal. What it is done, if you are not a signal processing background, then broadly you can think about like this, that suppose I want to know the frequency analysis of the signal. So, I have a time domain speech signal SN which I plot time versus sample value or amplitude. Now, I want to plot what are the frequency content in this signal. So, I say my y axis is the frequency, my x axis is the x axis is the frequency, and I want to know the each frequency content amplitude. So, then the power of every single frequency. So, this is a 2-dimensional plot, frequency versus power. This is also time versus sample amplitude. Now, the problem is that if I plot this way, then I do not know the time information. I want the time information should be there. So, what I do a spectrographic plot. How do I do it? I will discuss in the signal processing class. So, in x axis, this is time or sample, and y axis is the frequency, okay, and then the amplitude or power of the particular frequency is represented by a color. It may be color or it may be a black and white. So, black means the power is high, white means there is no power in this case. In this case, black means power is high, white means there is no power. So, I am not going details about the how the spectrogram is made, that I will discuss in the signal processing class. So, if we see in this picture, some portion are very dark, those contain the high frequency power of those portion are very high. So, if I see this y axis is the frequency axis, if you see there is a frequency axis. So, this is 2 kilohertz, 4 kilohertz, 6 kilohertz, 8 kilohertz. So, sampling frequency is 44 kilohertz. So, up to 20 kilohertz it is there, 22 kilohertz fs by 2. Okay. Now, if you see the black portion are contain the high power. So, if I say within 2 kilohertz most of the sections are black. So, that contain the high power. Okay. Now, if it is noise kind of sound, if you listen it, it is a noise. It is noise kind of sound. So, if this noise kind of sound, then you see the power distribution of the all frequency are present. Okay. So, there may be some dark portion are there, some light portion are there, but more or less there is all powers are there. So, I can say that if the random noise, the all frequency has some power. So, this is random noise. So, if I say who generate the random, what kind of manner of articulation generate those kind of random noise? If I say fricative or if I say aspiration. So, if it is fricative, that means friction noise will be there. So, I can easily say this is nothing but a fricative. Okay. Now, if I see here, there is no power at all in the frequency. If you see, there is no power at all. So, if we see the time domain, this is 0 sample value. So, that means this portion is silence. Okay. So, this portion is silence, this portion is fricative. If I say it, I can zoom out, this is fricative, this portion is voiced. So, it may contain voice consonant, it may contain vocalic sound, vowel, it may contain diphthong, it may contain semivowel, I do not know, but it contains some vocalic sound. So, vocalic sound look like this. Okay. Again, if I say showing this spectrogram, I ask you just spot out that fricative sound, easily I can say this was in fricative sound, this was in fricative sound. Okay. I can say find out the vocalic region. I can say here to here is the one vocalic region, here to here is the one vocalic region, here to here is another vocalic region. Okay. Now, if you see interestingly in here, if you go to the time domain, if you see there is a silence and there is a burst kind of noise is there. Okay. If you see there is a burst kind of things. If I go to the spectrogram, see no voicing, then burst, then aspiration, then voicing. So, I can say here there is either a plosive consonant is there, I do not know which plosive it is, but I can say it is a consonant which is plosive kind of nature, because there is a burst and there is a, if I say this is non-aspirated because there is no aspiration in here. So, I can say it is a unaspirated plosive is there. Okay. So, by seeing the spectrogram and the time domain waveform of the signal, I can find out some manner of articulation of the phoneme. I will show you. Suppose if you just open an some Hindi recording like this, let us open this one. If you listen it, this is ka, kha, ga, gha, all kind of things. So, if it is ka, ka, ka,
ka 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 ka, kha 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 kha, ga 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 ga, gha 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 gha, cha 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 cha, cha 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 cha.
There is a lot of noise is there, that is why upside frequency are present. So, if I forgot the noise, if I consider only this portion, is a silence portion. Okay, let us do the noise removal. There is this tool has provided the facility that I can remove the noise. So, there may be a 50 hertz noise in here. So, what I will do, there is a provision for noise reduction, analyze, let us transform, noise reduction, this subtraction noise reduction, it is procedure, I am not going details, but it is there. So, I can say the select the first silence portion, I can say this portion is noise portion. So, I can transform noise reduction, then I can say get profile, because this portion this is not sufficient to get the profile. So, I can effective size I can reduce, and then also it is not sufficient. So, what I will do, I will select much more whatever is possible, then try to find out noise reduction is then also I have to reduce it to okay, then just this one not possible. So, this one is possible, get profile, I get the noise profile, okay. Then I close it, then I control A, select all, then transform noise reduction, okay. So, what it will do, whole signal, because signal is very long, that is why it will take time, whole signal noise will be subtracted as per the sample noise I have given to the system. So, there are lot details are there, signal processing details are there, I am not going that much of details. Since the signals is noisy, that is why I am just cleaning the signal first, then I show you how the core is like that, what is the occlusion, what is burst. If you see now, if you see this portion, noise is reduced, almost noise is reduced. So, if I see, almost noise is gone. Now, if I see, listen it,
ka 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 ka,
okay. Now, it is clear.
ka ka.
Now, if you see ka 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 ka, so he pronounced ka 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 ka. So, ka followed by a vowel, again ka followed by a vowel, again ka followed by a vowel. So, I can say, if I zoom this portion only, so I can say, if you see, this is the if you see just little bit of unzoom, if you see this portion to this portion, this portion is transitory part. So, this is steady state vowel part. If I show you, so this black back color is gradually increasing, and here if you see that almost steady, then again if you see this is breaking, just follow the mouse, again start breaking. So, I can say this portion is nothing but a transitory portion when the vocal, when we want to pronounce after the vowel, I want to pronounce again ka. So, this is the transitory portion, transitory between vowels and consonant. So, if I say I am in here vowel, I want to produce a consonant, then there will be a vowel to consonant transition. That means that articulator is producing vowel, let us ka, okay. Then it want to produce vowel ko. So, what is the effect? The vocal cord has to be open and the articulator has to be closed. So, vocal cord opening is not started, but articulator is moving to close to produce the ko. So, once the articulator moving to close, the airflow is reduced, the sound in the, if you see the formant structure is changing from steady state vowel to consonant. Then if you see after here, no noise, no signal, if you see there is no signal, almost silence. So, this part I can say occlusion part. Then if you see there is a burst, here there is a burst, there is a burst. So, burst is happening, then there is a VOT. If you see voice onset time is very less. If you see here, if I zoom it and then I show you, if you see the after burst, vowels are not yet started. So, there is a delay between the vocal cord vibration and articulatory opening. So, what is done, this portion there is no signal, then the signal is started, then what is happening, again it want to produce ka to a. So, again articulator has to be go to position of o. So, there is a transitory movement to reach the steady state. So, I can say there is a VOT, then again there will be a consonant to vowel transition. Okay. So, now if I see, I can recognize, if I give you a signal, you can say this portion is nothing but a transitory portion, this portion is nothing but a occlusion, this is the burst, then this is a VOT, and then this is again consonant to vowel transition, again steady state vowel. If you look the waveform of the steady state vowel, almost all vowel period are same. So, I can say a 2 peak is period. So, I can say this to this is period, this to this is a period, or I can say here to here may be a period, here may be a period. So, I can say almost all period are same. Now, if I see the transitory portion, if you see the structure is not yet completed. So, I can say here to here is nothing but a consonant to vowel transition. That part vowels is steady state part called vowel steady state. Then again it will start from steady state to consonant transition. So, by seeing a waveform or by seeing a spectrogram, if you see the format structure, I am not showing you the format because this time I am not introducing the format here to see the format in spectrogram. Later on I can show you. So, but if you see this black portion is started breaking in this portion. So, I can say this portion is nothing but a consonant to vowel transition. Okay. So, after seeing a spectrogram, I can know the structure of a stop or plosive ko, where is occlusion, burst, VOT, again vowel, again occlusion, burst, VOT. So, ko. Now, if I say ko with kh, if you see kh. If it is kh, now if you see zoom it, this portion. If it is kh, if you see again consonant to vowel transition, occlusion period, burst, then if you see aspirated VOT, so long VOT. If you see compared to O, the long VOT which is totally aspirated, noise like of sound, aspiration is there, noise kind of aspiration is there. So, if you see there is a long aspiration, then I say this is kh. Okay. So, it is unvoiced aspiration, that is why I say it is kh, k to the power h. Okay. So, this is expression. So, difference between the k and kh, if I say what is the difference between the k and kh? K is unvoiced, VOT is unvoiced, but in case of kh, VOT is unaspirated, and in case of kh, VOT is aspirated. By seeing I can say. So, I can say I do not know, if I not listen the sound, I cannot say whether it is a ka or kha, but I can, seeing the spectrogram, I can say, at least I can say this is a some aspiration plosive consonant. Okay. I seeing the spectrogram, I can say this is a unaspirated plosive consonant. I do not know the place of articulation, because place of articulation if I want to know, then I have to know how the tongue is moving, because the difference between the ka and to, what is the difference? To is bilabial dental plosive, to is dental plosive and ka is velar plosive. So, if I say ka and ta, only difference is that tongue movement from a to ta and ta to a is different from ka to a and ka to a to ka. So, it is one is the velar opening, velar closure, another is the tip of the tongue touches the teeth to produce the to. So, cavity structure will be different that time. Okay. So, seeing the spectrogram, I can at least say what kind of manner of that consonant. So, this is kha. Again I can go little detail. Then if you see this is ga, let us see the ga. So, ga is nothing in Hindi ga, Bengali ga, or in ga is ga. Ga is whether it is English, Hindi, Bengali, the ga is voiced, unaspirated, plosive. So, if you see the voice, that means there will be a voicing during the occlusion. So, if you see the occlusion period, there is a voicing. So, I can say now since the voicing is there, then it is voiced. If you see there is a burst is also there, is a burst, then VOT is less. If you see the gha, let us I show you the gha, again if it is gha, if you see the aspiration will be there. Again VOT occlusion period is voiced, burst is there, and then see the aspiration is voiced. So, this pronunciation is a voiced aspiration. Okay. Ka, kha, ga, gha. Okay. Then if I say, I do not know, this is maybe cha, I think it is cha. cha. So, if it is cha, then if you see occlusion, friction, then VOT, very little VOT. Then if you see occlusion, friction, okay. Now, if I show you the cha, cha, let us come to the cha. Only difference is that if you cha is, if you see affricate. So, if you see cha, the aspiration, this is the aspiration part, this is the friction part, and then followed by an aspiration is also there. So, cha, cha. Now, if you see the ja, what is the difference? Only the occlusion part should be, instead of unvoiced, it is voiced, and then there is aspiration. Understand? So, cha, cha, then ja, jha. Okay. So, cha, cha, ja, jha. Okay. So, place of articulation I cannot say, but seeing the spectrogram from the manner of articulation I can say what kind of consonant it is. If you see the retroflex, I do not know whether the retroflex is cha, cha, ja, jha, this may be jha,
cha,
then that may be ta, I think so. If it is, I do not know, it may be ta. So, ta. So, see that again there is a burst, unvoiced occlusion. So, I seeing this waveform, I cannot say whether it is a ta, whether it is a ta, whether it is a ka, but I can say yes, it is a unvoiced, unaspirated flossing. Okay. So, at least manner I can say. So, if you look like the record your different kind of consonant with vowel and look like what kind of it is look. So, you can see the look. But if you closely watch the spectrogram, then you find in case of retroflex, the formant movement, that will be a formant structure. Here I cannot show you, but in part it is possible to draw the formant also. If you see the formant movement will be different. So, a consonant, whether it is ko, whether it is to, whether it is to, whether it is po, is only differentiate by the transitory movement from consonant to vowel or vowel to consonant. So, if I say the difference between the ka and ta only lies between the vowel to consonant transition and consonant to vowel transitory part, where since the movement of the tongue is different, that is why transition, movement of the transition will be different, frequency movement in the transition will be different. So, we only rely, I have to rely on this thing to find out whether it is a ko, whether it is a to, whether it is a to, whether it is a po. So, if I have a lot of confusion may be happen in signal processing between this group. Okay. And ko is difference by the ko is by only aspiration. So, if I able to find out the aspiration, then I can say yes, I can differentiate between the ko and ko, because elsewhere there is no signal. Okay. Occlusion is silence. Okay. So, seeing the manner, you can learn what kind of signal processing I should use for what kind of application. Then you have to know what kind of signal I am getting and what are the phoneme set, how it is behaved. So, I cannot say the result, consonant recognition result of English and consonant recognition result of Bengali may be different, because Bengali has more number of stop consonant compared to the English, stop and plosive. Even Hindi has more number of stop consonant compared to the English. So, identifying the voice consonant is easy, because voice there is some signals are there, some frequency composition is there. But if you see the difference between the ko, to, po is only the transitory part. This portion is silence, there is a burst, there is a BOT, and difference between the ko and kho is rely only on aspiration. So, if I want to find out the high accuracy, I may not get it between the ko and kho. So, that now there is another aspect is the co-articulatory effect. I am not showing you this is the nonsense pronunciation, the ka, 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 kha, 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 kha. The structures is very okay, means very well behaved, but if it is continuous pronunciation, if you see, I can show you in Bengali example. If I say I show you Bengali example that continuous things, let us say Bangla this one.
এই প্রদর্শনীর এ দুটোই হচ্ছে মস্ত বৈশিষ্ট্য।
So, if you see that the speech is continuous, so it may be
এই প্রদর্শনীর
a প্রভাবশালী. So, in words, when I write a or probably, so there is two words are there, but if you say the continuous speech, there is no word boundary is there, only continuous speech. So, that may be a vowel, that may be a pa, that may be a, if I say this is what kind of consonant, again it may be a bha, because occlusion period is voice, there is a burst and there is a tension. I do not know which kind of vowel it is, then I have to listen it, I can see it. Okay. Then I can say this may be a sha, because it is a friction. So, Bengali has a only pronounce the prabhab. So, sa is there, palatal so is mostly cases we pronounce the palatal so. So, it may be palatal so. So, it is so. So, there is a, if you see, there is no word boundary effect, there is no gap between the two words when you say in a continuous, but when I write it, there is a gap in a words. If I show you English example, if you see there is a no gap, okay, I can give you the number, all you can understand. So, if I show you number,
7, 5, 4, 6, 1, 2, 9,
all the
7,
number.
5,
Now,
4,
I can
6,
ask you,
1, 2, 9, 7.
based on the manner and seeing the spectrogram, can you identify the number? Okay. So, this kind of problem people may ask you that, okay, let us we do the signal processing later on, find out the speech processing later on, but seeing the number, if I say find out what should be the number this one and what should be the number this one. So, if it is a 7, it should be start by a friction. If it is a 7, then it should be start by a friction. So, that way I have to find out whether the words are different or not. Okay. Now, one things I can again show you, let us see this speech.
新たな薬局が時たますごい。
Okay. Now, when you learn, when you heard it, you cannot find out, if you do not know the Japanese, you do not know what it is spoken, or you cannot recognize the word, sentence, all kind of things. But if you heard the basic sound, you can understand the basic sound. Basic sound I can understand. So, I can say that some language, so that's why in the past I have said that to decipher the language is important to find out the sequence of phonemes to produce a meaningful pronunciation. So, all the sounds are there, all basic sounds will be same. If you can also see it, I will share this all sound file, you can see it. All the basic sound, if you see there is maybe a to, there may be a mo, there may be a no, all kinds of sounds are there, but if you see once I play it, I cannot recognize it because I do not know the language, but sound structure is same. That is why we say IPA, International Phonetic Alphabet, which alphabet represent the sound only, it does not depend on the language. So, ka, it may in Bengali exist, ko may exist in Hindi, ko may exist in Tamil, that sound may exist in Malayalam, that may exist in Japanese, that may exist in Chinese, that can exist in German also. So, phonemes are the sound, sequence of phoneme produce the message. Okay. Now, production of phoneme involve this part. So, there is problem. That problem is that some phoneme set maybe exist in Bangla, but it may not be exist in Hindi, or it may not be exist in English. Some phoneme which is exist in English, but not in Bengali. So what has happened? Suppose I produce the English, the speech which I produce in English language, sequence of sound is such a way that it follow the English language grammar, but what happening is that my English cannot be say it is the British English, how the British is pronounced. Because in case of British English, my mother tongue is first language is Bengali, so I learn that Bengali phoneme production. When I learn English, I try to copy that production with the English language. So that is called L1, L2 acquisition. So details I am not discussing, details are there. Okay. So there is another part also, segmental, suprasegmental, that part I will come later on. So what I am saying, it is a segmental property, that in a segment, what is the look like this. So this is called segmental property. Okay. So I request all of you to find out, to record or to analyze more number of speech signal, see it in spectrogram or time domain, try to find out manner of articulation of that production. If you see, there is a vowel transitory effect also there. If I say I have a Bengali sound, I think I have, I will show you sample English, that Bangla 2.
মশার জন্মের পর মশার জন্মের পর মশার জন্মের পর
So if you see, there is a word, one word is end and another word is begin, but there is no gap. It is a co-articulated, it likes a complete single word. So that details I will come later on. That so there is no gap. Main things is that there is no word boundary which is defined in speech signal. There is no silence. You cannot say that okay, this word is defined by this word. If there is a gap in written things, so there may be a silence in speech. No. All words are related with each other with a co-articulated effect. Then there is a prosody will come, then the silence will come based on the prosodic structure. So I am not coming that part. Okay. Then I can say the phonemes have a co-articulated effect. Ka followed by a, so there is a ka, then ka to a transition, then a to then o transition. So all kind of transitory movement will be there. Now if you see, there will be exist some combination which cannot produce by me, or which cannot producible. So that combination will not exist in that language. So if you see, there will you cannot find a case where there will be two aspirated sound will be clubbed together. That is not pronounceable. So if it is too aspirated, then one will be unaspirated, one will be aspirated. Okay. So depending on the how tongue movement restriction, some combination of the phoneme set does not exist for a particular language, or so that is not valid. So those kind of things also you learn. So then there is a called phonology, that the written words will not proper with the pronunciation words. So that part I will discuss in the TTS when I talk about the TTS phonology, that word to phoneme conversion. Okay. So now I'll request all of you to record the sounds and listen that sounds and find out what kind of consonant it is. Then you can say you can expertise your skill. I said one of the outcome of this course is that for a given signal you should able to level the signals. So for that skill development you should practice it. Let's that this kind of example I sometime given, that sometime I have given that I will give you some spectrogram and some words. Let's I say char, or I can say that 1, 2, let's 7. 3 words I have given. Now if I give the spectrogram of the 3 words and told you identify which is 1, which is 2, which is 7. Okay. Now if you see, all 3 are vocalic. This one is nasal murmur, 2 vowel. If you see, here starting is a stop consonant or plosive, then there is a to vocalic, 2. Then if you hear there is a fricative sound in here, then there is also nasal murmur ending, and then there will be a voiced consonant here. So I can say, seeing this is first one is fricative, then I can say it is 7. First one is plosive, 2. First one is vocalic, 1. That kind of things I can ask you. Okay. Another thing is that, okay, I have just closed it, again I open it. If you see that, I can show you how to see the pitch, fundamental frequency. Let us see here. So, this is the vocalic region, detailed signal processing I will discuss. If you analyze the frequency, if you see that, this is a frequency analysis. Okay. So, I say instead of linear view, I can make it log view. Okay. Now, if you see, this is the frequency representation, and this is the dB in power of the particular frequency. Now, if you see this, let us scan it with a little bit of high things. So, if you see, this is the first peak. So, first peak maybe is called fundamental frequency. Okay. So, I'll discuss the find out the fundamental frequency of a signal. Those methodology I will discuss. Why this is the one of the methodology to see the fundamental frequency. Okay. Now I can move this cursor to here, and I can see the scan again. Fundamental frequency may be changed. Okay. So the movement of fundamental frequency will be there. So that I will discuss later on. Let's not do it, but you should practice those things. Visualize different consonant. Find out. I can say you the level the occlusion period, level the burst, level the VOT, level the steady state portion of the vowels, then level a diphthong, then level a vowel combination. So those things are there in the slides, and once you practice it, you can be able to relate it. If you say that, or if you can give the feedback that okay, you have some difficulties, then I will again take a tutorial to show you those kind of consonant and those kind of vowel combination. Okay, thank you.